A solution contains 0.287 moles of NaCl in 425 milliliters of solution. Find the molarity. In order to find the molarity, we have to know the molarity formula. Molarity is calculated by dividing the moles of solute over the liters of solution. So now if we look back at this problem, we're given 0.287 moles, so that's our moles of our solute, in 425 milliliters of solution. So the equation calls for dividing by liters of solution. If we have 425 milliliters, we can convert that to liters by using a conversion factor. We know that 1 liter contains 1,000 milliliters. Our milliliters cancel out here. Our only unit is liters. And we would divide 425 by 1,000, giving us 0.425 liters. Now, if we plug both of these values back into our molarity equation, we will get 0.287 moles divided by 0.425 liters, giving us a molarity of 0.675 molar. Let's look at another one. How many moles of HCl are present in 1.75 liters of a 0.0825 molar HCl solution? There's a couple ways we can approach this. If we were to rewrite our equation as m over n divided by v, we can either just plug in the values that we have and then solve algebraically, or what might be easier is to rearrange the variables so that whatever we're solving for is by itself, in this case moles. Now moles is the n on the top of the fraction. If we want that all by itself, we need to get rid of v. We can get rid of v in a fraction by doing the inverse. So since we can look at it as 1 over v, we can multiply by v over 1. We have to do that on both sides, v over 1. A shortcut to this is just cross multiplying. But we will get n, our moles, equal to m times v. V has to be in liters, and m is just in molar. So the number of moles is going to be our molarity, which is 0.0825, times our liters of solution, which they gave us explicitly as 1.75 liters. When we multiply them together, we get n is equal to 0.144 moles, and moles is just given in MOL in lowercase abbreviation. This question is asking us what volume of 0.365 molar KOH contains 0.0525 moles of KOH. So this is a similar problem to the last one, except instead of solving for moles, we're solving for volume. We can start with our base equation, capital M equals N over V. This time we're solving for V. So the first step is to get it by itself. Right now we have that N variable in there. We can get rid of it by doing 1 over N. 1 over n on both sides, which is the same as just dividing by n. That'll give us m over n is equal to 1 over v. We don't want 1 over v, we just want v, which is v over 1. We can get that by flipping the entire equation. So to get v over 1, which is just v, we have to flip that fraction, which in turn is going to flip the fraction on the left. So instead of m over n, we're going to get n over m. Now v is all by itself, and we can plug in our values. We're given 0.365 molar, that's our m, and we're given 0.0525 moles. So we can put 0.0525 moles divided by 0.365 molar, and that will give us a final volume of 0.144 liters. Again, if we have the v variable in this equation, it's always going to mean liters. Let's add an additional step here. A solution is prepared by dissolving 18.6 grams of NaOH in enough water to make 350 milliliters of solution. Find the molarity. So we know the molarity is moles divided by volume. We have volume in milliliters, which we can easily convert to liters. However, we are not given moles. We are, though, given 18.6 grams of NaOH. And there is a direct conversion between grams and moles by using the molar mass. NaOH has 40 grams in 1 mole. And that's the conversion factor we're going to use. We're starting with 18.6 grams. We want to get rid of grams and only have moles. So we'll put 40 grams on the bottom, so then we can cross cancel. And there's 1 mole on the top per our conversion factor. So this is going to be 18.6 times 1 divided by 40. So we could just divide our number by 40. And that gives us 0.465 moles. Now we have our moles value, our N, for our equation. And we can get our V by converting milliliters to liters. So if we have 350 milliliters, we can use a previous conversion of 1 liter being 1,000 milliliters. Again, we're putting milliliters on the bottom because in the previous term it's on the top and we can cancel them out. 350 times 1 over 1,000 is 0.35 liters. So now we have converted all the terms that we needed to plug into our molarity equation. Capital M is equal to 0.465 moles divided by 0.35 liters. And when we do that division, we'll get a final answer of 1.33 molar as our final answer. Let's solve one more problem. And this one's asking us for 2 different pieces of information. So a student dissolves 24.8 grams of calcium chloride and prepares 750 milliliters of solution. Find the molarity of calcium chloride and then the concentration of chloride ions. The first thing we should do is get the molarity. We have 750 milliliters, we should know. We know that we need our answer to be in liters. We know we need our volume to be in liters, so we can quickly do 750 milliliters times 1 liter over 1,000 milliliters to get 0.75 liters. And again, we're not given moles explicitly, but we are given grams. We know we can do that grams to molar mass conversion. We have 24.8 grams. And the molar mass of calcium chloride is 110.98 grams per mole. That's going to be 1 mole on the top and 110.98 grams on the bottom. Again, so our grams cancel out. This will give us an answer of 0.223 moles. So after these conversions, we have the correct terms to plug into our molarity equation. Capital M, again, is equal to moles over volume. So 0.223 moles divided by 0.75 liters gives us a molarity of 0.297 molar. That's the first part of this question. The second part says to find the concentration of chloride ions. Well, let's write the dissociation equation for calcium chloride. Calcium chloride dissolves into Ca with a 2 plus and 2 Cl minuses. Since 1 calcium chloride breaks into 2 chlorine ions, we need to multiply our molarity by 2. The concentration, molarity is the same as concentration, and the concentration of our Cl is double that of the CaCl. So our 0.297 molar concentration is doubled to give us a Cl minus concentration of 0.594. Thank you for watching.